Now we are discussing about differential amplifier. In the last semester, you have studied when we are giving a signal V to an amplifier. If the Vin is the input signal, then the output will be AVN. If the output is AVN, then we are saying this amplifier is amplifying the signal with a gain A. Now we are taking the differential amplifier. Here we are giving two signals. One signal is V1, another signal is V2. For a normal amplifier, if we give V1, then the gain is AV1. If we give V2, then the gain is AV2. But we are giving two signals V1 and V2. This differential amplifier gives the output V0 A into V1 minus V2. This A is the gain of this differential amplifier. Why we are actually taking the difference of two signals? What is the necessity? We are happy with this amplifier. Why we are taking the difference? The problem is when we are amplifying this signal, we are getting some noise. Along with the AV2, we are also getting noise. So example, if we are amplifying the V1, we are getting some noise. And if we are amplifying the V2, we are getting some noise. If we are subtracting V1 and V2, the both noises will be eliminated. That is our intention. The common signal will be eliminated. That is our intention. But in reality, the common signal will not be eliminated. Even though we are attempting to eliminate it, the common signal is not getting eliminated. So here, we are expecting the differential gain, this one. So we are taking example, the output difference voltage is V1 minus V2. So this is the difference voltage, V1 minus V2. Now we have the common mode voltage, means the average voltage for these two. We are thinking that the common voltage is noise. That common voltage Vc is equal to V1 plus V2 by 2. This is equation 1. This is equation 2. From these two equations, we want to get V1 and V2. So here I am refining these equations. V1 minus V2 is equal to Vd. V1 plus V2 is equal to 2Vc. When we are, this is equation 3 and equation 4. When I am adding both the equations 3 and 4, now the result is 2V1 is equal to Vd plus 2Vc. So V1 is nothing but Vc plus half Vd. I am bringing the 2 here. So Vc plus half Vd. So this is equation 5. Similarly, when I am subtracting 3 from 4, then the output will be 2V2 is equal to 2Vc minus Vd. Therefore, V2 is equal to Vc minus half Vd. This is equation number 6. Finally, my intention is I want to relate both my V1 and V2 with the common mode voltage and the difference voltage. Common mode voltage, I have taken the average of the V1 plus V2. V1 and V2. So the average is V1 plus V2 by 2. If example, we are giving only V1 and we made V2 as 0, then the output will be A1 V1. And if we are taking V1 as 0 and only V2, then the output is A2 V2. So what we have done? We have removed one voltage input and we checked what is the output, and we removed another voltage and we checked what is the output. Now the total output should be always the combination of A1 V1 plus A2 V2. So this A1 V1 we got when V2 is grounded, and A2 V2 we got when the V1 is grounded. The summation of these two should give the output voltage. Already we know this V1 is nothing but from the equation 5, A1 into Vc plus half Vd, and similarly A2 into Vc minus half Vd. When I am taking Vc as common, this will be A1 plus A2, and when we are taking the differential voltage Vd as common, Vd by 2 as common, then this is A1 minus A2. Now you see Vc into, I am calling this A1 plus A2 as AC for my convenience, and I am calling this A1 minus A2 by 2 as AD for my convenience. So this is a differential gain I am calling, and this is common mode gain I am calling. We want to eliminate this common mode gain. We want to reduce this common mode gain. Elimination is not possible. At least we have to reduce. So now we are defining a new term called common mode rejection ratio, CMRR. So this common mode rejection ratio is how much differential gain you are getting and how much common mode gain you have. We want to make it as 0 ideally, then the CMRR will become infinite. So we are calling this with one letter, either you can call it as a P or rho. I am giving some name to it. P, AD by AC, differential gain by common mode gain. We need a differential gain, but we don't want a common mode gain, but it is coming because of the noise. Now this should be minimized. I want to write this as an expression of the V0, because finally I want to see my output voltage. So V0 is equal to, I am taking Vd AD common from this equation. I may call this equation 7. When we are taking Vd AD as common, then this will be 1 plus Vc AC by Vd AD. So this is equal to Vd AD 1 plus AD by AC is P, but AC by AD is 1 by P into Vc by Vd. This is the final expression. So the relationship between the output voltage and the differential voltage and the differential gain, this is the common mode signal, this is the differential signal. Vc is equal to V1 plus V2 by 2, Vd is equal to V1 minus V2, this is CMRR. This is the ratio of the differential gain to common mode gain. This CMRR value we get from the manufacturer of that particular IC, and then we get the differential gain value from the manufacturer of that particular IC. We have to calculate the Vc and Vd because we are giving our input signals. In our hands we have Vd and Vc because we know what is V1 and V2. But manufacturer will give the CMRR value and differential gain value. From these two values we can calculate the output voltage practically. So if I give some V1 and V2, because the manufacturer gives what is CMRR and the manufacturer gives what is differential gain, we can calculate what is the exact output of this differential amplifier.